By the end of the Second World War, there was one aircraft the German people feared hearing more than any other. Not because it was the fastest, not because it was impossible to shoot down, but because when its engines appeared over the horizon after sunset, entire cities disappeared before sunrise. The Avro Lancaster would become the most successful heavy bomber ever built by Britain. It dropped more bombs than any other aircraft in RAF history. It destroyed dams, factories, railways, submarine pens, oil refineries, bridges and battleships. It carried the largest conventional bombs ever used in combat. It flew the Dambusters Raid. It hunted down the Tirpitz. And by the end of the war, it had become the backbone of Britain's strategic bombing campaign against Nazi Germany. But none of it was supposed to happen. The Lancaster was never the original plan. It wasn't Britain's first choice. It wasn't even Britain's second. In fact, the aircraft that would go on to define RAF Bomber Command only existed because the bomber it replaced was turning into one of the greatest engineering disasters of the war. This is the story of how one failing aircraft company transformed catastrophe into the bomber that helped destroy Nazi Germany at night. In 1936, Britain was watching Europe grow more dangerous by the month. Across the English Channel, Adolf Hitler was rebuilding Germany's armed forces at a pace few politicians had believed possible. The Luftwaffe was expanding rapidly. New tanks rolled out of German factories. Warships entered service. Military aircraft appeared in numbers that violated every restriction imposed after the First World War. Britain had begun ramming, but not fast enough. If another European war erupted, the Royal Air Force needed aircraft capable of striking Germany itself. Not simply supporting troops on the battlefield, it needed bombers that could fly hundreds of miles into enemy territory, deliver devastating payloads, and return home through darkness and hostile skies. To make that possible, the Air Ministry issued Specification P 1336. The requirements were among the most demanding ever given to the British aviation industry. The new bomber had to fly farther, carry heavier bomb loads, operate at higher speeds, and remain affordable enough to build in large numbers if war broke out. Every major aircraft manufacturer wanted the contract. Winning meant years of production and a central role in Britain's future air force. Among the competitors was Avro Company, better known simply as Avro. Avro was respected. Its engineers had designed successful aircraft before, and its trainers had helped prepare thousands of RAF pilots. But by the late 1930s, the company lacked a truly world-class combat aircraft. Its future depended on winning this competition. Leading the design team was Roy Chadwick. Unlike many aviation pioneers of his generation, Chadwick avoided publicity. He rarely sought interviews, rarely gave speeches. He preferred solving engineering problems quietly behind a drawing board. Colleagues respected him for one reason above all others. He had an extraordinary ability to simplify complexity. Where other engineers added weight, Chadwick often removed it. Where others designed around problems, Chadwick tried to eliminate the problem entirely. The aircraft that could define his career was now sitting on his desk. Avro's answer became the Manchester. At first glance, it appeared exactly what Britain wanted, a modern twin-engine medium bomber built around the new Rolls-Royce Vulture engine. The Vulture promised more than 1,700 horsepower, making it one of the most powerful aircraft engines ever developed. Using 2 large engines instead of 4 smaller ones would reduce drag, simplify maintenance, and lower production costs. On paper, it looked like the future. If the engines performed as promised, the Manchester would become one of the most capable bombers anywhere in the world. Everything depended on a single assumption, that the Vulture engine would work. The Manchester made its first flight in July 1939. Just weeks later, Germany invaded Poland. Britain declared war. Every prototype aircraft suddenly became a frontline priority. There would be no years of peaceful testing, whatever Britain possessed would have to fight. The Manchester entered production almost immediately. Factories accelerated assembly. RAF squadrons prepared to receive what they believed would become one of the country's principal bombers. From the outside, everything appeared to be unfolding exactly as planned. But inside Avro, warning signs were already emerging. The Vulture engine was proving unreliable. Small mechanical failures were becoming major ones. Test flights ended early. Maintenance crews struggled to diagnose recurring problems. Each report looked manageable on its own. Together, they pointed towards something far more serious. Britain wasn't just risking a new bomber, it was risking an entire strategy. And before long, Roy Chadwick would face the decision that would either destroy Avro forever or create the most famous bomber Britain would ever build. Roy Chadwick did not waste time arguing with reality. The Manchester was failing, and every week that passed meant more crews flying an aircraft that everyone inside Avro knew had a fundamental weakness. The Vulture engines were becoming impossible to trust. Rolls-Royce had bigger priorities, focusing its resources on the Merlin engine that powered Britain's fighters. If the Manchester was going to survive, Chadwick would have to save it himself. His solution sounded almost ridiculous. Instead of trying to improve the twin-engine bomber, why not remove the two unreliable engines entirely and replace them with 4 smaller, proven Merlins? On paper, the idea looked expensive and complicated. 4 engines meant more fuel systems, more maintenance, more weight, and a completely redesigned wing. But Chadwick saw something everyone else missed. 4 reliable engines were far safer than 2 powerful ones that might fail without warning. If 1 Merlin stopped, 3 remained. If 2 stopped, the bomber still had a chance. The mathematics of survival changed overnight. It was no longer simply about speed or bomb load. It was about bringing crews home. The redesign happened at astonishing speed. The centre section of the wing had to be strengthened. 2 additional engine nacelles were added. The cooling systems, fuel plumbing, electrical wiring, landing gear loads and flight controls all had to be recalculated from scratch. Yet beneath the changes, much of the Manchester remained. The fuselage, the cockpit, the tail, the production tooling. Keeping these components allowed Avro to avoid starting from zero. Every day saved meant bombers reached the RAF sooner. In wartime, months could decide entire campaigns. The Air Ministry agreed to the gamble. The project initially carried the uninspiring designation Manchester 3. Nobody yet realised it would become one of the most famous aircraft in history. Construction began while Britain was still fighting for survival. German bombers continued attacking British cities. Factories worked through the night. Engineers slept beside drawing boards. Production workers knew many of the young men who would eventually fly the aircraft they were building. This was no ordinary engineering project. Every bolt represented someone's chance of coming home. On January 9, 1941, the prototype lifted into the Winter Sky Chief Test Pilot H.A. Bill Thorne took the controls. Many expected another disappointment. Instead, almost immediately, something remarkable happened. The aircraft felt balanced, stable, predictable. Even with one engine throttled back, it remained controllable. With 4 Merlins producing over 5,000 horsepower combined, performance exceeded expectations. The aircraft climbed better, handled more smoothly, carried heavier loads. Most importantly, it inspired confidence. That single quality had been completely absent from the Manchester. The test reports surprised nearly everyone. Instead of creating a more complicated bomber, Chadwick had accidentally produced a better aircraft in almost every measurable category. The extra engines did not simply improve reliability, they transformed the airplane. Its maximum range increased, its ceiling improved, its payload grew dramatically. Future upgrades suddenly became possible because the aircraft had reserve power available. The Manchester had reached the limits of its design. The new bomber had barely begun. The Air Ministry quickly abandoned the Manchester name. This was no longer a modified aircraft. It deserved its own identity. It became the Lancaster. Orders arrived before testing had even finished. Factories already producing Manchester components were instructed to transition immediately. Assembly lines changed while the war continued around them. Workers barely paused. The need for heavy bombers had become desperate. Pilots noticed the difference the first time they climbed into the cockpit. The Lancaster felt forgiving, large enough to carry enormous loads, powerful enough to keep flying after suffering damage that would destroy many other bombers. Mechanics appreciated something else. The Merlin engine had already proven itself across Britain. Spare parts existed. Ground crews understood its maintenance. Reliability improved overnight. An aircraft only fights as often as it can fly. The Lancaster could fly again and again and again. Still, nobody believed the Lancaster would become legendary. It entered service quietly in early 1942. No grand ceremony, no newspaper headlines, just another bomber arriving at RAF squadrons during the darkest years of the war. Its first operational missions appeared almost routine. Night raids over occupied Europe, industrial targets, rail junctions, ports, factories. The bomber performed exactly as promised. Dependable, powerful, predictable. The qualities crews valued more than anything else. But within months, RAF commanders began noticing something unexpected. Whenever planners asked whether a target was simply too large, too distant, or too heavily defended, the same aircraft kept being selected again and again. The Lancaster was slowly becoming the Royal Air Force's first choice for missions that no other bomber could accomplish. Soon it would receive a target unlike anything aviation had ever attempted. A target hidden deep inside Germany, protected by mountains, guarded by anti-aircraft guns, and believed to be completely impossible to destroy. The mission that followed would make both the Lancaster and its designer immortal. By the spring of 1942, the Lancaster was finally entering squadron service. At almost the exact same moment, Britain changed its entire strategy for fighting the war. The Royal Air Force stopped trying to destroy Germany during the day. From now on, it would attack almost exclusively at night. The reason was simple. Daylight bombing had become suicidal. German fighters could see incoming formations from miles away. Radar stations tracked every approach. Heavy anti-aircraft batteries filled the skies with steel. Bombers were being destroyed faster than Britain could replace them. Night offered one advantage: darkness. Accuracy suffered dramatically, but survival rates improved enough that Bomber Command could continue the offensive. The Lancaster had been designed almost perfectly for this mission. It could carry more bombs than any other Allied bomber in Europe. It flew high enough to avoid much of the flak. It had the range to reach almost every major industrial city inside Germany. And perhaps most importantly, it was remarkably easy to repair. Crews often returned with enormous holes in their wings, shattered control surfaces, damaged engines, or sections of fuselage missing entirely. Ground crews worked through the night. By sunset the next day, many of those aircraft were airborne again. The Lancaster was becoming more than just another bomber. It was becoming Britain's weapon of attrition. The man responsible for turning Bomber Command into an offensive force was Air Chief Marshal Arthur Harris. His strategy was brutally simple. Germany had bombed British cities. Now Britain would bomb German ones. Instead of targeting individual factories, Harris believed entire industrial cities should be attacked simultaneously. Rail yards, power stations, machine factories, oil depots, warehouses, worker housing. Destroy everything. The Lancaster was the only aircraft Britain possessed that could make this strategy practical. On the night of May 30th, 1942, Harris launched Operation Millennium, the first 1,000-bomber raid. More than 1,000 bombers crossed the English Channel toward Cologne. Hundreds of them were Lancasters. The sight was unlike anything Europe had ever witnessed. A river of aircraft stretched across the night sky. Their navigation lights remained dark. Only the moon reflected faintly off hundreds of wings. The raid dropped over 1,400 tons of bombs. Large sections of Cologne burned. The military damage remains debated to this day. The psychological impact did not. For the first time, Germany experienced destruction on a scale previously associated with blitz attacks against Britain. And the Lancaster was only getting started. As production accelerated, Avro continuously improved the aircraft. New radar, better defensive guns, more reliable Merlin engines, improved navigation equipment, longer operational range. Every month the bomber became slightly better. Factories across Britain worked around the clock. Workers built Lancasters in Manchester, Chadderton, Yarden, Castle Bromwich. Even Canada began producing them. Soon hundreds became thousands. Eventually, over 7,300 Lancasters would leave the production line. The bomber that almost never existed became Britain's industrial masterpiece. Then came Hamburg, Operation Gomorrah, July 1943. For 8 consecutive days and nights, RAF Lancasters and American bombers attacked one of Germany's largest cities. The RAF struck at night. The Americans attacked during daylight. It was the first sustained round-the-clock strategic bombing campaign in history. Lancasters carried enormous loads of high explosives, followed by thousands of incendiary bombs. The first wave blasted open rooftops. The second wave ignited everything underneath. Entire districts caught fire simultaneously. The flames merged. Temperatures climbed beyond 800 degrees Celsius. The rising heat created hurricane-force winds that pulled oxygen into the inferno from every direction. People were literally dragged toward the flames. A firestorm, an entirely new kind of urban destruction. More than 35,000 people died. The devastation shocked even some within Bomber Command. For Germany's leadership, however, the message was unmistakable. No city was beyond Britain's reach. No factory was safe. No night belonged entirely to Germany anymore. The Lancaster had become the backbone of Britain's strategic bombing campaign. But one target remained beyond its reach: Berlin, the capital, the political heart of Nazi Germany. Harris believed destroying Berlin would end the war. Beginning in late 1943, wave after wave of Lancasters crossed occupied Europe toward the German capital, night after night, week after week. Sometimes more than 700 bombers participated in a single raid. German defences became increasingly sophisticated. Searchlights illuminated the sky. Radar-directed flak batteries filled entire sectors with exploding shells. Night fighters waited above the bomber stream. Losses mounted. Some raids saw dozens of Lancasters fail to return. Entire crews vanished into the darkness. Young men barely in their 20s disappeared without witnesses. Back in England, empty beds waited in barracks. Ground crews prepared aircraft that would never land again. The Lancaster had proven itself capable of reaching Berlin. Now it had to prove Britain could survive the cost. Because soon, Bomber Command would be asked to attempt something no Air Force had ever dared before. And for that mission, the Lancaster would have to become something even bigger than a bomber. The Lancaster had already become Britain's most important bomber, but its most famous missions were still ahead. Not because they involved the largest formations, not because they dropped the greatest number of bombs. Because they demanded something almost impossible: precision. In 1943, British engineer Barnes Wallis proposed an idea so unconventional that many believed it would never work. Germany's great dams, the Möhne, Eder and Sorp, powered factories, supplied fresh water and supported the industrial heart of the Ruhr Valley. Destroy the dams, and entire regions of German industry could be thrown into chaos. The problem was that the dams were heavily defended. Anti-torpedo nets protected them from underwater attack, while anti-aircraft guns surrounded the reservoirs. Conventional bombs were almost useless. Wallace designed something entirely different. A bomb that spun backwards before release, dropped at exactly 60 feet above the water, released at precisely 232 miles per hour. If everything was perfect, the bomb would skip across the surface like a stone, leap over the torpedo nets, strike the dam wall, sink, and explode underwater where concrete was weakest. No bomber in Britain could carry it, except one. The Lancaster. Even then, extensive modifications were required. The bomb bay doors were removed. A special mounting cradle was fitted beneath the fuselage. Twin spotlights were installed so crews could judge their altitude at night. For weeks, pilots practiced flying just a few dozen feet above reservoirs in complete darkness. A single mistake meant hitting the water. On the night of May 16, 1943, 19 Lancasters took off from England. Operation Chastise had begun. By dawn, 2 of Germany's largest dams had been breached. Millions of tons of water rushed through the valleys below. Factories flooded. Rail lines vanished. Power stations shut down. The military impact has been debated ever since. The psychological impact has not. The Lancaster had proven it could accomplish missions no other heavy bomber in the world could even attempt. Barnes-Wallis wasn't finished. As the war continued, Germany built enormous reinforced concrete bunkers for U-boat pens, V-weapon sites, and underground factories. Conventional bombs simply exploded against the surface. Wallace responded by designing the Tallboy. Weighing 12,000 pounds, it penetrated deep into the earth before detonating, creating an underground shockwave powerful enough to collapse foundations. Only the Lancaster could carry it. Then came the Grand Slam. At 22,000 pounds, it remains one of the largest conventional bombs ever used in combat. Again, only the Lancaster possessed the bomb bay and lifting power required. Roy Chadwick had unknowingly designed an aircraft capable of carrying weapons that did not even exist when he drew its first blueprints. It was one of the greatest examples of engineering foresight in aviation history. By 1944, the Lancaster was no longer just bombing factories. It was shaping the outcome of the entire war. In the months leading up to D-Day, Lancasters attacked railways, bridges, fuel depots, communication centres and troop concentrations across occupied France. The goal wasn't simply destruction, it was isolation. Every destroyed railway delayed German reinforcements. Every demolished bridge bought precious time for Allied soldiers landing in Normandy. On the night before June 6, 1944, hundreds of Lancasters crossed the English Channel. When the first Allied troops landed the following morning, much of Germany's transportation network in northern France had already been crippled. The bomber was helping win the war long before the first infantrymen stepped onto the beaches. As Germany's fuel supplies disappeared and the Luftwaffe weakened, Allied bombers increasingly dominated the skies. Lancasters ranged across the Reich almost at will. One of their final legendary missions came against the German battleship Tirpitz. Hidden deep inside a Norwegian fjord and protected by mountains, anti-aircraft batteries and torpedo nets, the battleship had survived years of Allied attacks. In November 1944, Lancasters carrying Tallboy bombs finally succeeded. Several direct hits capsized the giant warship. One of the most powerful battleships ever built was destroyed by an aircraft that almost never existed. When Germany surrendered in May 1945, the Lancaster had flown more than 156,000 operational sorties. It had dropped over 600,000 tons of bombs. More than 7,300 Lancasters had been built. No RAF bomber contributed more to Britain's strategic bombing campaign. But victory came at an extraordinary cost. Over 3,200 Lancasters were lost. Nearly 22,000 aircrew never came home. For many bomber crews, surviving a tour of 30 operations was statistically less likely than surviving frontline infantry service. Every mission demanded courage. Every takeoff carried the possibility of never returning. The Lancaster was never the fastest bomber of the Second World War. It wasn't the most heavily armed. It wasn't even the most technologically advanced. What made it extraordinary was its balance. It could carry heavier bomb loads than almost any aircraft of its era. It could adapt to entirely new missions. It proved exceptionally reliable. And it remained relevant from the darkest days of 1942 until the final weeks of the war in Europe. Its success wasn't born from perfection. It was born from failure. The Manchester failed. Roy Chadwick refused to let that failure define Avro. Instead of making small improvements, he fundamentally reimagined the aircraft. He added 2 engines, redesigned the wings, expanded the bomb bay, simplified what didn't work. And in doing so, he created one of the greatest bombers ever built. The Lancaster was never supposed to become Britain's greatest bomber. It was simply supposed to replace a failure. Instead, it became one of the aircraft that changed the course of the Second World War. Sometimes history isn't changed by the aircraft everyone expects to succeed. Sometimes it's changed by the one that was never supposed to exist. If you enjoyed this story, make sure to subscribe for more deep dives into the aircraft, engineering breakthroughs, and untold stories that shaped World War II. And let me know in the comments, which legendary aircraft should we cover next? Thanks for watching, and I'll see you in the next video.